very quick comment, if I can remember where that was now. Oh, I gave up on the Eric Dollard's analog computer because although it's an ideal circuit for amassing a surge that wants to go to infinite oblivion, there's no way to regulate it. I've tried so hard. I've even tried isolating every single component out of each module of the daisy chain of LMD analog computer, and all I managed to succeed at doing was grounding out the voltage. The amperage remained on the capacitors as they were, so that when I would reconnect the components, it would pick up where it left off, as if nothing had ever happened. And that's like, what? So that's not manageable. It's too strange a circuit to regulate it. There's really no equivalent. I've never seen anything like it. It's really stands in a class all by itself. So I need something more plebeian, more pedestrian, something that can be destroyed so that it goes back to zero again, because if you can't turn the thing off, then you're going to end up with a fried mess and a non-repeatable appliance. As an appliance, it's, you want something you can depend on, and this is not dependable. One-time use, and then you got to go get another circuit to use it all over again per surge, which happens like in a picosecond. Come on, that's not even reasonable. So I've been working diligently on trying to figure out how to regulate this thing, and I have not succeeded, or I haven't even gotten to that point yet. Instead, I took a different turn, and I thought to myself, well, there's another problem I have to settle first, and that's the battery. Because a battery of 1 microvolt amounts to nothing, and all it's doing is creating a voltage difference between the two hollow spheres. So, how come I can't use a pre-charged capacitor? Well, it's never worked in the past. Until now. Here in this example, I put negative resistance in my resistors. All of them. All the resistors have negative resistance. And after it's stable for a while, and then after a while it starts to take off. As you'll see, if I restart this, where's my cursor? Yoo-hoo, cursor. Oh my god. Oh. Okay. Alright, so if I restart this, the spark gap voltage is going up. That means eventually the spark gaps are going to fire when it hits a high enough value, and then it'll just take off. Right now it's microvolts. Now that the capacitor here is pre-charged with 1 microvolt. So even with that pre-charged condition, it's not immediate over unity. We still got millivolts on the spark gap. Yet that doesn't stop the inductor, but the inductor is zetawatts, so that's like nothing. Gotta wait till those spark gaps fire. And the capacitor's up to nanovolts, but that's... So where are we at here? Spark gap is up to 5 volts. It'll take off in a little bit. It's very slow. Wow, that is slow. Maybe I can speed it up. That's still pretty slow. Come on now, speed up here. Oh, it's jerky, that's it. It's not moving because it's jerky. Okay, I can't speed it up. wait a minute. I think I can speed up the time frame. Yeah, it's just taking a long time to compute everything. There, it's almost going to fire now. These are normal spark gaps, not neon bulb spark gaps. Did they fire? No, not yet. Oh wait, they're firing. I think. The right one is. No, the left one too, maybe. Oh yeah, they're up to 4 kilovolts. It's hard to tell. Well, anyway, the overall... Yeah, it looks like they're firing. Let's see, you know what? I have to just put my cursor here. There, yeah, it's on. Oh, it's on all the time, on and off. Yeah, they're firing. So, yeah, up to kilovolts, 20 kilovolts. So, anyway, this was the attempt here, but it turns out that this isn't the right way to do it. And so we go over to here. Now what I've done is I've taken out all the resistors, and I've raised the capacitances to 1 farad. All the capacitors are 1 farad. And I've put in a pre-charged capacitor here in place of the battery. And it's 300 microfarads with an initial charge of negative 100 microvolts. So 1% of 1% of 1 volt. And then I kept this the same, but raised the inductance on these 2 coils to 1,000 ohms each. And made the series resistance negative equal to their inductance. So negative 1,000 ohms on each of these series resistance, and negative 1 ohm on this coil here. It has to be on all 3 coils, negative resistance equal to the inductance. And despite that gimme, or, you know, it still is troublesome getting this thing to operate in over unity. It's not that easy. So by regulating it, let's see, 30 seconds, and by regulating the capacitance of this capacitor, and by regulating the amount of charge on it, and also regulating the time frame, 3 different variables, I managed to get on the coil, on the load coil, I managed to get an AC waveform, high frequency, of 450 volts positive and negative, but that's the volts. But the amperage is simply an exponential curve that goes straight up. It used to be up and down, but eventually it predominates in the positive, going exponentially straight up, and it hits around 2.2 kiloamps. And that proportional relationship is very similar to the Tesla Motors car, what's delivered to the motor of that car, and also similar to what Sangalani Maxwell Chikumbutsu, although he has half this voltage, but this is closer actually to the Tesla Motors car. And that's not bad, in 30 seconds. Now let me read you this little ditty. All 3 coils possess negative resistance equivalent to their negative inductance. It may be possible to achieve this by winding the coil's magnetic wire with non-insulated iron ribbon or non-insulated iron wire before winding the coils. So before winding these 3 coils, you wrap them, they're insulated magnetic wire, you wrap them with non-insulated iron wire or iron ribbon. This is exactly the transatlantic telegraph solution that Heaviside solved back in the 1800s. And it's also exactly what Nathan Stubblefield specifies in his patent. Now, he doesn't specify to wind the copper wire with iron ribbon, but he does specify that the copper wire is sheathed with a sleeve of cotton cloth. And he doesn't say to wind it, and so actually, when he specifies the windings, he has 3 windings. He's got a primary and a secondary. It's a transformer, basically. He called it a battery, but essentially it's a transformer with a 3rd winding, and the 3rd winding is the load winding. And he planted it beneath the roots of an old oak tree and waits a year. Now, the oak tree is pretty much one of these spheres, one of these hollow spheres, this combination sandwich of 2 capacitors and a spark gap in between that's grounded to something. And in this case, a tree is a grounded aerial. So it also serves as an antenna, but it's also a grounding rod as well. So once it comes in union with that tree, now he's got himself an electrical generator. And according to the Ammann brothers, C. Earl Ammann, according to him, the newspaper reporter reported him, quoting him as saying that you can scale this thing to any size. And that's what I did. I scaled it, the here and here, and I scaled it all. Oh, and the capacitance on these capacitors, the more you raise them, the faster this thing escalates. So that's another variable to consider. So I think they're all using the same technique, and they're all in the same era, so they're all thinking alike. But who would think to take the telegraph cable solution that Heaviside was the author of and coil it? They have it stretched out across the Atlantic, but you go and coil the thing, and now you've got yourself a coil of very interesting properties. Now, Tesla, not to be left out, he has a patent, but it's different. He layers his copper winding, followed by iron winding, followed by copper winding. And the way he says it, he says, oh, the iron winding is serving as the magnetic core that's going to transfer between the 2 copper windings. That's true. That's the way most people think of transformers. But what if he actually winds it differently? What if he actually doesn't stack the 2 different windings, but actually creates a bifilar winding? Which is what Nathan Stubblefield specified in his patent. But I'm specifying here the more extreme case. I've never tried, I don't know if it needs to be done, is to wind the iron wire around the copper wire before winding that package around your transformer core. And when you think about it, when you wind a insulated copper cable with bare iron wire or iron ribbon, the iron ribbon or iron wire is going to be longer than the copper cable. So you would think you can have more resistance. Why bother doing that? No, because it carries the magnetic fields superbly all the way down the line. And that's what I'm supposing is the analogy to the negative resistance on these 3 coils. Because I think that's what ends up happening when you start to coil this combination of insulated copper wire and non-insulated iron wire. You get something really weird happen. Because you've got the electricity going straight down the junction of the iron winding, since it's not insulated, yet you have it wrapped helically around the copper cable, creating a direction for the magnetic flux to spin tangential or helically around the copper cable as it travels down the length of that copper cable. So it's a very interesting juxtaposition that I'm proposing. That's not quite what Nathan Stubblefield specifies, nor what Nikola Tesla specified in one of his patents. I'm trying to be true to Heaviside, which may not be workable. You know, you may not be able to wind that kind of package around a transformer core. I'm just supposing. What if? If it's just a bifilar winding, so be it. You know, the 2 wires are in parallel with each other as you wind them around the core of the transformer, so be it. Because you're going to be winding the primary and the secondary together anyway as it is, so that's 4 wires. Well, at least 3. That's right, at least 3. So instead of merely assuming that we're going to have iron in the center of the core and maybe even iron around the outside, you know, the steel drum or surrounding, I'm assuming that was not a wood barrel that the Ammann brothers were using. Nathan Stubblefield dealt with wood. His armature was created out of wood. He did have an iron bolt down the center, so he had an iron core, but that was the extent of the extra iron in his device. But how much iron there is in the core, shell, or both. To put iron in the winding as well, spaced in between the copper windings, that's a hell of an idea. That's not something you see or hear about every day of the week. And yet I think that's what we need to do to make the Ammann Brothers circuit work without the use of a battery. So now I'm taking the newspaper article seriously, literally. There was no battery at all. Because when you think about it, 100 years ago, what did they need a battery for? The headlights, that's it. I mean, what do they need a battery for? They don't need, and they took out the headlights. So they did not need a battery anymore. And so I have to take it seriously that, quote, verbatim, there was no battery at all in the car. But a pre-charged capacitor is what I'm assuming what Tesla did in his Pierce Arrow experiment, that's what was inside the project box, was a pre-charged capacitor. And I've discovered that Mark McKay's description of Nikola Tesla's favorite mixture to slather in between his coil windings actually is an electret recipe, but a different proportional relationship. Mark McKay said 5% carnauba wax, and the remaining amount of material was 50% beeswax and 50% tree rosin. Well, in an electret recipe, it's 45% carnauba wax, and then some other kind of ratio between the beeswax and the tree rosin. But it's the same three ingredients that has traditionally been used for electret recipes. And as you know, an electret is the equivalent of a permanent magnet. You make a mold, you put in the electret material in a liquid state, you charge it up with high voltage and hold that voltage as it solidifies, and then it stores that capacity for a certain length of time. In some cases, according to the Wikipedia article I read, it can be for like, 100 years or something? It's absurd. So you can have an electret capacitor in here, electret style capacitor that has 300 microfarads of capacitance and negative 100 microvolts, no problem. 1% of 1% of a volt shouldn't be a problem to store in a sizable, and this isn't a very large or a very small, well, this is not something out of the ordinary for a size capacitor, so it's not bad. It looks like this circuit is buildable, at the very least. And it safely reaches the values for an EV within half a minute. So it shouldn't be too hard to manually operate this thing. Somehow, I have no idea at the present time how you regulate this. I'm imagining that each of these three components have to be disconnected from the bottom part here and then maybe pulsed into and out of the circuit. But if I try to do it in LT Spice, I can't do it because I have to put a resistor-oriented switch. And anytime you do that, the voltage goes straight across and only the current is being prevented from getting across the switch, and that's not a switch. In my book, a switch is zero current gets across and zero resistance gets across. You might have surges when you open and close the switch, but when the switch is open, nothing gets across. So I'm not sure how to simulate that in LT Spice, so I've given up trying. So I think it'll be up to me to just put in fuses at each of these junctions and then see what pops first. Whatever pops first is probably the best place to put the switch to control this thing, and then manually switch in and out. Hopefully you're not left with any residual charges on the capacitors such that it carries over when you close the switch again and you just pick up where you left off. That's no good. It has to be, some configuration has to be possible to short out both sides of these capacitors, as well as or maybe also disconnect them from the circuit, or both, or either one, I don't know. Something to get this thing back down to a zero state so that this thing can be tweaked, because this thing can be tweaked. It doesn't have to take 30 seconds to get this far. It certainly can. You can do it in half a second if you like. Any amount of time, you pick your values, all of your various parameters that you can play around with, and you can get just about any result you want. So that's not an issue. All right. I think I'm finished. I've taken this as far as I need to develop it, despite the fact that it's incomplete. But I'm confident enough that I think it is possible to do this thing.